Hi, welcome to our VB Developing channel. Hope everyone is well. Today we are here with Data Science Part 15, Pandas tutorial. In this video we will discuss about reading and writing data using pandas in Python as we discussed before in Part 14. So in this video, we will discuss following 6 things, as you can see here. So let's get started. First we will know about reading and writing HTML files. Also with regard to the HTML format, pandas provides the corresponding pair of I/O API functions. Read_HTML for read HTML files, and to_HTML for write HTML files. To have these two functions can be very useful. You will appreciate the ability to convert complex data structures such as data frame directly in HTML tables without having to hack a long listing in HTML, especially if you're dealing with the World Web. The inverse operation can be very useful, because now the major source of data is just the web world. In fact, a lot of data on the internet does not always have the form ready to use, that is packaged in some text or CSV file. Very often, however, the data are reported as part of the text of web pages. So also having available a function for reading could prove to be really useful. This activity is so widespread that it is currently identified as web scraping. This process is becoming a fundamental part of the set of processes that will be integrated in the first part of the data analysis, data mining and data preparation. Alright. To reading and writing HTML files, you need to install a library called HTML5lib. Just type here this command and press Enter key. Then installing will be start. But here we don't press the Enter key, cause we have already installed this library. Alright, first we will know about writing data in HTML files. Now you see how to convert a data frame into an HTML table. The internal structure of the data frame is automatically converted into nested tags th, tr, td, retaining any internal hierarchies. Actually, you do not need to know HTML to use this kind of function. Because sometimes the data structures as the data frame can be quite complex and large, to have a function like this is a great resource for anyone who needs to develop web pages. To better understand this potential, here's an example. You can start by defining a simple data frame. Thanks to the to_HTML function, you have the ability to directly convert the data frame in an HTML table. Alright. Let's see the example. Now we will import some library. Let's see the example. As you can see the data frame. Now we will write this data frame into a HTML file. Now you can see here we got a HTML string as output. Alright, as you can see, the whole structure formed by the HTML tags needed to create an HTML table was generated correctly in order to respect the internal structure of the data frame. In the next example you'll see how the table appears automatically generated within an HTML file. In this regard, we create a data frame a bit more complex than the previous one, where there are the labels of the indexes and column names. Now you focus on writing an HTML page through the generation of a string. This is a simple and trivial example, but it is very useful to understand and to test the functionality of pandas directly on the web browser. First of all, we create a string that contains the code of the HTML page. Now that all the listing of the HTML page is contained within the variable HTML, you can write directly on the file that will be called myframe.html. Alright, first we will show you our directory. And now you can see here we don't have any file, namely myframe.html. As you can see here, now here we have a HTML file. Now you can see here we got a data table. Now we will know about reading data from a HTML file. First, you need to install a library called lxml. Just type here in terminal and press enter. So, here I've already installed this library, so I don't press the enter key. As you just saw, pandas can easily generate HTML tables starting from dataframe. The opposite process is also possible. The function read_HTML will perform a parsing an HTML page looking for an HTML table. If found, it will convert that table into an object data frame ready to be used in our data analysis. More precisely, the read_HTML function returns a list of data frame even if there is only one table. As regards the source to be subjected to parsing, this can be of different types. For example, you may have to read an HTML file in any directory. For example, you can parse the HTML file you created in the previous example. Now we will read that file, which we created as before. Alright, as you can see here we got data from HTML file. As you can see, all of the tags that have nothing to do with HTML table are not considered absolutely. Furthermore, web_frames is a list of data frames, although in your case, the data frame that you are extracting is only one. However, you can select the item in the list that we want to use, calling it in the classic way. In this case, the item is unique and therefore the index will be 0. However, the mode most commonly used regarding the read_HTML function is that of a direct parsing of an URL on the web. In this way, the web pages in the network are directly parsed with the extraction of the tables within them. For example, now you will call a web page where there is an HTML table that shows a ranking list with some names and scores. Alright, in this case, here we will use Wikipedia website. Alright, as you can see here, list of countries by population, we will read this data through programming. Alright, as you can see here we got data from Wikipedia website. Notice here, 239 rows and 6 columns. The same operation can be run on any web page that has one or more tables. Now we will know about reading data from XML. In the list of I/O API functions, there is no specific tool regarding the XML, extensible markup language, format. In fact, although it is not listed, this format is very important, because many structured data are available in XML format. This presents no problem, since Python has many other libraries, besides pandas, that manage the reading and writing of data in XML format. One of these libraries is the LXML library, which stands out for its excellent performance during the parsing of very large files. In this section you will be shown how to use this module for parsing XML files and how to integrate it with pandas to finally get the data frame containing the requested data. In this example you will take the data structure described in the XML file to convert it directly into a data frame. To do so, the first thing to do is use the submodule Objectify of the LXML library, importing it in the following way. Now we will show you the XML file, which is we go wanna use. As you can see here, this is the XML file. As you can see, here we got an object tree, which is an internal data structure of the module LXML. Look in more detail at this type of object. To navigate in this tree structure, so as to select element by element, you must first define the root. You can do this with the getroot function. Now that the root of the structure has been defined, you can access the various nodes of the tree, each corresponding to the tag contained within the original XML file. The items will have the same name as the corresponding tags. So to select them, simply write the various separate tags with points, reflecting in a certain way the hierarchy of nodes in the tree. Now you can see here we got first name as output. In this way you access nodes individually, but you can access various elements at the same time using getChildren. With this function, you'll get all the child nodes of the reference element. Now you can see here we got all the child nodes. While with the text attribute you get the value contained between the corresponding tags. Now you can see here. However, regardless of the ability to move through the lxml.tree structure, what you need is to convert it into a data frame. Define the following function, which has the task of analyzing the entire contents of a tree to fill a data frame line by line. Let's execute it. Now you can see here entire contents of a tree to fill a data frame line by line. Alright, so you can see all the code. Now we will know about reading and writing data on Microsoft Excel files. In the previous section, you saw how the data can be easily read from CSV files. It is not uncommon, however, that there are data collected in tabular form in the Excel spreadsheet. Pandas provides specific functions also for this type of format. You have seen that the I/O API provides two functions to this purpose: to Excel, read Excel. As regards reading Excel files, the read Excel function is able to read both Excel 2003.xls files and Excel 2007.xlsx files. This is possible thanks to the integration of the internal module XLRD. First of all, you need to install OpenPixel library. I have already installed this library in my machine. First we will read an Excel file, which I have in my directory. Now we will show you the Excel file first. Now you can see the Excel file. And here we have two sheets in this file. So now we will read this file through the pandas. Alright, now you can see the data, here we got from that Excel file. As you can see, by default, the returned data frame is composed of the data tabulated in the first spreadsheets. If, however, you'd need to load the data in the second spreadsheet, and then specify the name of the sheet or the number of the sheet, index, just as the second argument. Now you can see here we got second sheet data. Now we set the index instead of sheet 2. Now we got first sheet data, as you can see here. The same applies for writing. So to convert a data frame in a spreadsheet on Excel, you have to write as follows. Now you can see the data frame, so now we will write this data into a spreadsheet on Excel. Now you can see here we don't have a file, namely mydata2.xlsx. So, let's execute it. Now you can see here. Now we will know about reading and writing JSON file. JSON as JavaScript object notation has become one of the most common standard formats, especially for the transmission of data through the web. So it is normal to have to do with this data format if you want to use the available data on the web. The special feature of this format is its great flexibility, though its structure is far from being the one to which you are well accustomed, such as tabular. In this section you will see how to use the read JSON and to JSON functions to stay within the IOAPI functions discussed in this chapter. But in the second part you will see another example in which you will have to deal with structured data in JSON format, much more related to real cases. Let's begin with the more useful case, that is, when you have a data frame and you need to convert it into a JSON file. So, define a data frame and then call the toJSON function on it, passing as argument the name of the file that you want to create. Let's see the example. Now you can see the output. So now we will write this data into JSON file. Now you see here, after execute the program here we got a JSON file, which was we mention our code. Alright, now we will read a JSON file. Now you can see here we got data from JSON file, which was created just before. The example you have seen is a fairly simple case in which the JSON data were in tabular form, since the file my.json comes from a data frame. Generally, however, the JSON files do not have a tabular structure. Thus, you will need to somehow convert the structure dictionary file in tabular form. You can refer this process as normalization. The library pandas provides a function, called json normalize, that is able to convert a dictionary or a list in a table. First you have to import the function. As you can see, the file structure is no longer tabular, but more complex. Then the approach with the read.json function is no longer valid. As you learn from this example, you can still get the data in tabular form from this structure. First you have to load the contents of the JSON file and convert it into a string. Now you can see, this is our JSON file. This file we go wanna using my code. Now you can see the output, we got title and price from JSON file. The function will read the contents of all the elements that have books as key. All properties will be converted into nested column names while the corresponding values will fill the data frame. As regards the indexes, the function assigns a sequence of increasing numbers. However, you get a data frame containing only some internal information. It would be useful to add the values of other keys on the same level. Now you can see the output once again. Now we will know about how to interact with database. Basically here we discuss with two type of database, which was we mentioned in parentheses. To interacting with databases you need to install a library called SQL Alchemy. So here we just type this and press enter. But here we don't press the enter key, because we have already installed in my machine. In many applications, the data rarely come from text files, given that this is certainly not the most efficient way to store data. The data are often stored in an SQL-based relational database, and also in many alternative NoSQL databases that have become very popular in recent times. Loading data from SQL in a data frame is sufficiently simple, and pandas has some functions to simplify the process. The pandas IO SQL module provides a unified interface independent of the DB, called SQL Alchemy. This interface simplifies the connection mode, since regardless of the DB, the commands will always be the same. For making a connection you use the create engine function. With this feature you can configure all the properties necessary to use the driver, as a user, password, port, and database instance. So first we will know about loading and writing data with sqlite 3 database. Now here we import create engine from SQL Alchemy. As a first example, you will use a SQLite database using the drivers built-in Python sqlite 3. sqlite 3 is a tool that implements a DBMS SQL in a very simple and lightweight way, so it can be incorporated within any application implemented with Python language. In fact, this practical software allows you to create an embedded database in a single file. This makes it the perfect tool for anyone who wants to have the functions of a database without having to install a real database. SQLite 3 could be the right choice for anyone who wants to practice before going onto a real database, or for anyone who needs to use the functions of a database for the collection of data, but remaining within a single program, without worry to interface with a database. Create a data frame that you will use to create a new table on the SQLite 3 database. So now we will create a database. Now you can see the output data. So now we will write this data into a table inside the sqlite database. Alright, first we will show you our directory, because we doesn't any file namely testdb. Now you can see here, after execution we got a database file called testdb. Instead, to make a reading of the database, you have to use the read_SQL function with the name of the table and the engine. Now you can see the output. Here we got data from that sqlite database, which was created just before. Now we will know about MySQL database. To use MySQL database, you need to install MySQL client library. Just type here this, and press enter key. I have already installed in my machine, so I don't press the enter key. So here we using same data frame as we used before. Let's try to understand the connection string. So now we will go to MySQL Workbench. Now you can see here, user as root, and next password field. So similarly here, root as user, and after colon was password, and after at localhost as server name and after /world as database. Now you can see here the database. And inside the database only 3 tables are present. Now we will create a table inside the world database. Now see here, when we execute the program then colors table will be created here. Alright, just here we refresh once. Now you can see the table colors. And see the data inside the table. As we saw before in sqlite database. Instead, to make a reading of the database, you have to use the read_SQL function with the name of the table and the engine. As you can see here. In this chapter, you saw how to use the features of the I/O API of the pandas library in order to read and write data to files and databases while preserving the structure of the data frames. In particular, several modes of writing and reading according to the type of format are illustrated. In the last part of the chapter you have seen how to interface to the most popular models of database to record and / or read the data into it directly as data frame ready to be processed with the pandas tools. In the next chapter, you'll see the most advanced features of the library pandas. Complex instruments like the group by and other forms of data processing are discussed in detail. So friends, our today's video was up to this. Thanks for watching the video. See you in the next video. Please subscribe our channel and don't forget to like and share the video. Thank you.